Hi everybody, welcome back to day 2 of Unit 3 functions. Today we're going to be talking about domain and range. So domain and range is stuff that you've seen before, but we're adding on to it to make it a little bit more complex, to make the algebra come out a little bit more, okay? So let's go ahead and get started. First, our definitions. The domain is a set of all the x values of a function. So remember, we talked about what a set looks like, okay? It's like the group of all the things. So it's a set of all the x values in the function. The range is a set of all the y values in the function. Okay? Sorry, school just let out, so it's going to be really noisy. So, reminder about set builder notation. We are going to be using this unit as well. Set builder notation lets us know what the set is. It kind of gives us the rule of everything that's in the set, so we know what's allowed. So here it says the set of all x such that x equals 3. So that's only going to be one number in the set, because that's only one possibility. There's only one number that equals 3. But we could have different rules. It could be like, it has to be if all the x's as long as x is greater than 3. Or x can be 3, 4, 5, and 6 or something. Okay, so we're going to be adding on to the set builder notation. Notation for domain and range. So when we are writing domain and range, normally, not in set builder notation, just normal notation for domain and range, there's 3 things. It always must be in braces, okay? All the numbers must be in order from least to greatest, and there can't be any repeating numbers, okay? No repeating numbers whatsoever, okay? So if you have 6 is a y that appeared twice, only write 6 once in the set. Okay, the set's just saying, like, what's a possibility? Like, what can I pull from here that's going to be a y value in the function? Okay? Okay, so make sure you keep these in mind. So I think, here's a little chart, just how to set it up. Okay? All the different representations, this is where you're going to find your domain and your range. So in mapping, your domain is always going to be in that first bubble on the left, your x values. The range will always be in the ending bubble, so your right side. Okay? Ordered pairs, the domains are going to be your x coordinates, your range will be your y coordinates. The table is going to be your independent variable. Sometimes it's labeled xy, sometimes not, especially if we're talking about a real world situation. You're going to have to figure out what the independent variable is. Remember, that's the one that doesn't depend on anything. Okay? It's going to happen no matter what. The range will be your dependent variable. So that's going to depend on what's going on with the independent variable. Oh. Oh. Not sure why this is going off. It's going to be annoying. Okay. Graphs are going to be the x value for the point and the y values for the points. And it's talking about all the points being used. Okay? Okay. If I'm going a little too fast, don't forget to pause the video. You can pause the video at any time. Okay? So here we're going to go into our examples. Okay? So example 1, this is just a set of ordered pairs. For the ordered pairs, all the x values here, we have 9, 4, 7, and -5. Those are our x. That's our domain. Okay? So I need to make sure that it's in braces. I ordered them from least to greatest, so -5, 4, 7, and 9. Okay? And if I had any repeats, I just would write it once, but I don't have any repeats. The range are all the y values, so the 5, 6, the 5, and -1. So here's one that repeats. So I'm only going to write it once in the range. So I have -1, 5, and 6. Even though 5 appeared twice, that's okay. I just need to write it here, because it's just saying, what are the possible numbers that I can have for a y value? Okay? 2 is our table. So here's one. They didn't tell us what x or y was. But if you think about it, your distance depends on how long you have to do something, okay? So your time's not going to change depending on how fast or slow you're running. Time doesn't slow down because you feel like going slower. Time doesn't speed up because you feel like running down the hall. You know, some of you think so, okay? So our time is actually our independent variable, and distance is our dependent variable. So here, already in order from least to greatest, so my domain is just 0, 2, 4, and 6. My range, the distance, 4, 5, 6, and 7. Oh, goodness, I have no idea why things are beeping, and I don't know, it's only 2:55. So, weird. Number 3, we're talking about mapping, okay? Again, first bubble, that's all of my x values, so I just need to put them in order from least to greatest and not do the repeats. So -7 is the least, -1, 3, 4, 6. The range is the second bubble, I only have 2, so -2 and 4. Done. Okay? And this is a function because each one only has one arrow coming out of it. Alright, these next two are going to be a little bit different for you. Domain and range for a graph. Now when we have a graph, now this is where it's new. We don't just have a bunch of points and like we can write them out as ordered pairs. Here we have continuous lines. So everything this line is touching is a point. Okay? So we've got like -1.9999999, comma, -1.999, all these like decimals are now possibilities. Okay? So instead of stressing ourselves out and trying to write an infinite number of points, which is what is covered with these lines, we can write it as an inequality. Okay? So if we look at the x values, we have x values going from -2, everything between -2 and -1 is being used here and here. Okay? Everything from -1 to 0 is being used here and up here. Same thing from 0 to 1. We're covering all of it with a line. Okay? So I'm actually using every number in between there. Same thing from 1 to 2. Okay? So really I'm covering every x value, every little itty bitty annoying decimal point between -2 and 2 with this continuous line. Okay? So my domain, and this is where it comes in handy for the step builder notation, instead of writing out what every single value for x can be, I just write it as an inequality. That's all I need to do. It's a set of x such that x is between -2 and 2, and this is how I write it as an inequality. -2 is less than or equal to x, and x is less than or equal to 2. Okay? So both, that whole big inequality is called a compound inequality, and we'll do more practice with this stuff. It just says it's between -2 and 2. Okay? The same thing with the range. I'm using every single y value between 2 and -2 because I have a continuous line from there to there. Okay? So again, my range is very similar to my x. It's a set of every y such that -2 is less than or equal to y, and y is less than or equal to 2. Okay? Alright. Let's move on to another graph. So here's another graph. If you look at the arrows mean it's going to keep going. It's going to keep going this way and this way. Okay? So look at our x values for domain. I'm using every single x value here because I've got a continuous line going from -10 to 10, but those arrows mean it's going to keep going. So I'm not just going from -10 to 10, I'm actually going from -infinity because I don't know when that arrow is stopping. Okay? To positive infinity because I don't know when this arrow is going to stop either. So it's going to look like this. From -infinity is less than or equal to x, which is, not equal to, is less than x, which is less than infinity. Okay? And I didn't put equal to because we can't equal infinity. We don't get, and blah, 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 9, infinity. No, that doesn't happen. Okay? Infinity is like a concept. It's somewhere out there, we can't ever reach it, so we can't actually equal it. Okay? So, and we'll, again, like I said, we'll do more practice with how to write these, okay? Alright. The range, the y values. Now here it's only going from 4 to -4 on my screen. With those arrows, it's going to keep going down, it's going to keep going up. So really, I'm going from -infinity to positive infinity again. Okay? Let's see if I can move it up. -infinity, which is less than or equal, or less than y, which is less than infinity. Okay? Okay, I know this is a little bit more difficult, and we'll definitely spend time on this in class, okay? So the next couple are try on your own. There's 5, I think. I know one of them for sure we're going to go over in class, and that's the graph one of the curves, the 2 curves. We'll definitely be going over that in class, instead of me just giving you an answer, because I know I'm going to get questions on it anyway. So we'll save that one for class. So here, let's go ahead and try these on your own. A, B, and C should be no problem for you. D, I can foresee because I picked a hard one. E, go ahead and try it yourself though, okay? Pause the video and come back, I'll have the answers. Okay, so here the answer we get is the domain is -3, -1, 0, and 4. The range, oh, I forgot something. It won't let me type it. I got brace 0, 5, 6, and your answer should have a brace on it, okay? But I only have 4 here because I repeat the 6's, okay? So I don't want to repeat it. Alright, B, my answer is way down here for some reason. Oh, that's why, because it's really big. Here's my answer. I've got domain is -2, or -3, -2, -1, 0, and 1. My range is -7, -4, -2, -1, 0. Okay, because I want to make sure I write it in order. Next one. My answer, oh goodness, I don't know why it won't let me have it. Quick, quick. Oh, it's annoying now. None. Enter. Oh, it's being very odd. Weird. Okay, well it just doesn't, there we go, okay. Sorry, it took so long. Really? Okay, I don't know what's going on with it. Here the answer is, sorry I can't show you the problem and the answer, but my domain is -5, 0, and 2, my range is -4 and 5. So this one we're going to do on our own because this actually has like extra stuff in it that I didn't think about before. It looks good, but we're going to try this. We're going to do this one in class, so. Okay. Button domain range of this guy, and hopefully you saw there were little arrows on it. Okay, so that means it's going to keep going down, it's going to keep going up, it's going to keep going to the left, it's going to keep going to the right. I did that wrong. Here we go, domain and range. Your domain is going from -infinity all the way on this side to this side to positive infinity. Your range is going from -infinity to all the way over here to positive infinity. Okay? So we'll definitely go over this more in class. If you have any questions, please write them down or put a star next to it, and I'll be happy to help you next time in class. Alright? I'll see y'all later. Have a good day. Bye!